Everyone can see my screen? Just, I don't know, say if you can't see it. Okay, awesome. So like I said, this is our second workshop and we're gonna be going through problem statements through organizing results. So first we're gonna do some introductions for us. So hi, I'm Jessie. I'm the current Vice President of Outreach of the SLB. I'm in the 12th grade and I advise for biochemistry.
Hi, I'm Sanjana. I'm also a 12th grader and I advise for environmental science.
Hi, I'm Eleanor. I'm a sophomore and I advise for biochemistry.
Hi, I'm Kate. I'm also a 12th grader and I advise for biochemistry as well.
Hello, my name's Jessica. I'm a 10th grader and I advise for engineering.
Hi, my name is Anjana. I'm a junior and I advise for behavioral and social sciences.
Hi, my name is Ainsley and I'm a sophomore and I advise for behavioral and social sciences.
Margaret, can you go?
Hi, my name is Margaret. I'm in 9th grade and I advise for product and consumer testing.
Lynn?
Hi, my name is Lynn. I'm a senior and I'll be advising medicine and health sciences.
Awesome. And Emily?
Hi, I'm Emily. I'm a senior in high school and I'll be advising for engineering.
Yep, awesome. So these are all the people who will be presenting today and helping run the breakout rooms. So if you know the category that you will be competing with your project in, you might want to go to one of the rooms where someone who advises for your category will be giving some advice about how to succeed in your specific category, and they'll have very specific project advice. All right, so I'm just going to go briefly over some updates for the fair in case you missed our first workshop or haven't seen our website. So our fair will be fully virtual next year. However, all the safety and digital project screening is the same as usual. We have a safety screening deadline on December 31st, and we'll have a little bit more on that in the presentation. And then we have a digital project screening where you create a slide deck and you fill out this template for your project, and that's in February. So this is all the same as usual. However, you must still keep a project notebook, which is why I have this on the side. So this is the sample project notebook from our website, and we'll be using this as we do the presentation, so you know exactly how to order and write your notebook. Some additional details are that this year we are not requiring a backboard. We only require the project notebook in terms of content besides this slide deck that we have here. So we don't need a backboard. We discourage group projects due to social distancing guidelines, and the application fee is reduced this year. It's $25 per student. We are also recommending a video about your project, a pre-recorded video. However, I don't have any specific details at this time because we're still working that out. So please keep updated on the website and our social media. And then we're planning to have virtual judging, much like a virtual interview, where you make a digital slide deck using PowerPoint or Google Slides, and then you'll present your slide deck to judges in real time. And we advise that you take pictures while you do your experiment so you can put them into this slide deck. And this will be like I said, a virtual interview. And they may ask for your notebook for you to refer to it or to hold it up. So you will need that for judging. So these are all the details I have now. If you have any specific questions, I would recommend putting them in the chat. But we don't know a lot. We just know that we're working extremely hard to get the fair done this year. So please advise to everyone that we are still doing the fair. It's just going to look very different than normal. All right, let's start.
Okay, so here's a brief look at our agenda for today. So we're going to start off by talking about how to write your statement of problem or purpose and the differences between a science and engineering project. Also, we're going to cover hypotheses, materials, writing up your procedure, gathering results and organizing that data. And then if you have individual questions, like Jessie mentioned, please stay afterwards because there will be project-specific advising in the breakout rooms. And if you have any questions, please wait till the end, or you can always ask them in the chat. So it'll also be really helpful for you to follow along in our sample notebook, which is located on the GSD-SEF website. And these presentations are meant to help you write your notebook and guide you through that process, and also cover the components in the sample. And just a reminder that having a notebook is required for this year's fair. So there are some differences between science versus engineering and CS projects. So a science project is one that collects data and analyzes trends within that data. And for a science project, you need a statement of problem as well as a hypothesis. For an engineering project, it looks a little bit different. You make prototypes and you don't always have to generate data. But these projects are also completely fine and accepted at our fair. So to give you an example, the difference between a science versus engineering project, a science project would be if you bought a rocket model and then tested different variations, like different fuels, or if you changed a variable to see how it affects the height of the rocket. Versus an engineering project would be if you yourself built a prototype of a rocket. So that's the difference between the two things. And if you have questions about what your project is categorized at, you can always ask that in the breakout rooms afterwards.
So the statement of problem is only for science projects. It can be both questions or statements, and it gives an idea of the problem, and it can also give an idea of why it's important. For more information, you can also refer to the engineering notebook on the Greater San Diego website. So the hypothesis is also for science projects. It's a prediction of what you think will happen based on some of your background research, and it uses the independent variable, or the variable that you change, and the dependent variable, or the variable that you measure. So a nice simple way to put your hypothesis would be to use the if-then format. So you would say, if the independent variable changes in however way, then the dependent variable will be affected in another way that you're going to predict. So some examples of the hypothesis are that a higher concentration of aloe vera juice will decrease the regeneration time in planaria. Or if you wanted to use the if-then format, you would say, if higher concentration of aloe vera juice is given to the planaria, then the regeneration time is decreased. If you had an experiment about radish seeds, your example hypothesis could be radish seeds watered with higher concentrations of acidic water and higher concentrations of alkaline water will result in decreased germination as compared to lower concentrations in neutral water. Or if you wanted to use the if-then format for a different project, you could say, if temperatures are raised in orange juice, then absorbic acid concentration levels will decrease. If you haven't made your hypothesis yet, then I would advise you to think about the independent and dependent variables in your project. And if you have more questions, then wait till the end and you can ask them in the breakout rooms later.
Okay, so for statement of purpose, this is what you're going to do if you're doing an engineering project or computer science project. So you sub out the statement of problem and hypothesis with a statement of purpose and a design objective. So your statement of purpose explains why you are building what you're building. Why is your product useful to the real world? And then the design objective is what you're actually building. What's the purpose of what you're trying to build? So in this example here, so the purpose of this computer program is to model the flow of various chemicals through different types of soil and groundwater. This would be your design objective. Your statement of purpose would explain why this is useful. So this is useful so that people can find problematic chemicals and can clean them up. So one explains why you need it, and the other explains what you're actually doing in your experiment. So if you're unsure of what type of project you have, you can always ask afterwards, because there are a lot of projects that are halfway between engineering and science projects. For materials, this is going to be a bulleted list of everything that you use in your experiment and project. You want to make sure you're concise with your materials. You don't need to go into super depth. However, make sure you do use numbers and units. And when doing that, make sure you use the metric system. Be sure to take pictures of your materials to put in your report later as well. So here's an example of a basic material list. So your procedure is an explanation of exactly how your experiment was done. You can write it in either a step-by-step, bulleted list, or numbered list, or in paragraph form. Someone should be able to exactly reconstruct the data trends and experiment from your description of the procedure. So make sure you include things like brands and timings. So we recommend that you use a passive voice, but if you want to, you can always use an active voice. So an example of a passive voice would be 20 milliliters of acetic acid were added to the test tube. But the active voice would be, I added 20 milliliters of acetic acid to the test tube. Both are acceptable at the fair.
So this is an example of a procedure that is a numbered example. And so I'll just go through a couple of them. So like 10 250 ml plastic cups were filled with 100 grams of garden soil, which equals the control, which is 2 times more of the trials. And 10 250 milliliters of plastic cups were filled with 100 grams of Miracle's Grow soil, which is two more times of those trials. And so we really recommend that you use lots of numbers when you are telling about the trials. And something that's really important is that you really want to take pictures of when you are doing the experiment, because that is necessary for this year's presentations. So lastly, you do need enough trials and to have a sizable sample size. And so if you don't already know, trials are how many times you repeat the experiment for every set of conditions. And a sample size is how many data points are in one trial. And so we recommend having a good number of both, depending on the type of experiment you're doing. And what what you read in your research can help you determine how many trials and how big of a sample size is acceptable in your field. And so generally we recommend having 3 to 8 trials, but it all depends on what kind of project you have. So this is a quick reminder that once you're finished with your procedure or engineering design, you'll need to submit your project to safety screening before you start your experimentation. So please ask us any safety screening specific questions in the breakout rooms, which will be held after this presentation. And everyone has to make an account, which basically means that you have to fill out a short safety form on the website and a signature page that, and upload it to the safety form on the website. However, if your project needs certification, you may have to fill out additional forms. Also, check out our YouTube series that explicitly goes through all of the steps, and don't hesitate to ask us any questions in the chat room or DM or email us later.
Yeah, so as you start your experiment and stuff, you'll have all your results. So after you collect your data, it's very important to organize them. So you need to organize them in tables. And so there's some strategies to do that. For example, you could organize your just raw data in tables with the rows or columns having the independent or dependent variables. And then later on, you can also graph it with that. And then I'll talk a little bit more on that later. But then you should also write down all your data, since it's a good practice to keep all your data, because later on you may not know which data you do need or you will not need. So Excel or Google Sheets is good for that. So you can later on easily graph it. And then graphing your data also helps you illustrate trends that you can't just like see from a glance. So it's important to start graphing. So these are just briefly parts of a table and how to make a table. So as you can see, there's the independent variable on the left, which is time. And then on the dependent variable is growth in centimeters. Sorry, independent variable is weeks. So as you can see, it's 0, 1, 2, 3 is the week. And then the trials are all in centimeters. So trial A, B, C, those are all the independent variables. And then you should also label your table and trials with titles, and then make sure that to label your variables with units. So centimeters, days, or weeks, just so your reader knows what are you exactly analyzing. So even though these may be like very in-depth and they may be difficult to understand at first glance, the more organized your tables are and then your graphs are, the easier they will be to graph. So it's important to graph it, and then which is where you really get your conclusions and results. So this is a getting a graph from a scatter graph from a table. So as you can see, the weeks, the independent variable, and then the height, the dependent variable. So as you can see then in the graph, what we did was we plotted the, so this is, we'll start off with the axes. So the independent variable is on the x-axis, weeks, and then the dependent variable is on the y-axis, height in centimeters. And then when we start plotting our points, we would start with 1.5. So you can see you first go to weeks 1, and then you move up 1.5. So you can see that that's where the point is plotted. And then second, same is weeks 2. So you would go to weeks 2 and then move up to 2.6 centimeters. So then you can see the data point that's plotted there. And then same thing with week 3. You first plot the x-axis, week 3, and then you move up to 3.4. So we have all these workshops in different ranges of levels. So even though yes, this might be simple, but there's always like you use the basics to build up to the more complex. So it's great to learn the basics as well. Yeah, and then at the end, you can either create a trend line, or as we created here, there is a line that connects all the points together. And then later on, the next 2 workshops that we will cover, we'll cover data analysis in more depth, as well as how to use some basic graphing software.
All right, thank you everyone for coming to this short presentation for slides. Right now, we're going to break out into these breakout rooms, and they're numbered here. I'm gonna open them in 1 second. But this was just a brief overview of how to first construct your notebook, because we know that a lot of students are in a wide range of stages for their projects. And so we really wanted to touch on everything very briefly, which is why we want to break out into rooms now so you can ask very specific questions. Again, with the data analysis, that is actually a very important part of science fair. However, we're holding more advanced and in-depth data analysis workshops. We're actually holding 2 in December. So please mark your calendars. We're having a basic data analysis workshop where we do more like what we did today with learning how to graph a scatter plot and a bar graph and other types of basic data graphs. And then we'll have an advanced data analysis where we'll go more into things like linear regression and statistical analyses. And so, yeah, I'm going to keep this up for a second. Sanjana, are there any chat questions that were particularly interesting that we should go over now before we go into breakout rooms?
No, I think we're good. I think we should just reestablish that this meeting will be recorded and posted on the GSDSEF YouTube channel in the coming days.
Okay, thank you.